Well, so good. And that's the unit 5. It means one more unit to go. I hope the previous videos has been helpful for your revision. Okay, so let's take calculus. That is a rate of change. And during the lecture period, we talked about it being a derivative of functions like the polynomials, the exponential functions, trig, logarithms, constants, and what have you. You can find the rate of change of all these functions. So I wouldn't delve much into that. I'll go straight to the applications. We talked about the application as a marginal utilities, where we considered the total cost as a variable function. We had some revenues, we had some profit, and we have to find a marginal profit, marginal revenue, marginal cost. So assuming I have a total cost, it has some fixed, a total cost given as, I have my examples already written, so let me use that in my Excel. I have a total cost for production at 8x squared plus 30. So on the same preamble, assuming the manager produces his movie with this total cost, then I can find the marginal cost. The marginal cost MC becomes the derivative of the total cost. That is d, the t or the x of the total cost. I'm differentiating the total cost with respect to x. I can use the power rule here, and there's a constant. I'm differentiating a constant, I'm differentiating a polynomial. If I differentiate this, I'm going to get 2 times 8x plus 0. That is simply 16x. The power rule says that if I have x to the power n, then I'm to differentiate x to the power n, I'm going to get n, x n minus 1. So that is what I've applied here. You can verify that. Here my n is 2. So 2 times the initial coefficient I have. 2 minus 1 gives me 1. And so I have 16x. But we don't write 1 as a superscript on variables. Now, if I know the revenue function, which is given as 5x, revenue is, so I need to find the price first. This is how much he produces the movie if he's given a price function. So a price function P as, what did I use here? 5 minus 2x. And so how he came by that, we are not so sure, but this is not to scale. We are just using it. If this is the profit, then I can find the marginal profit, price of the production. Then I can find the revenue R as the variable times the price. That'll be x times 5 minus 2x, which is going to give me 5x minus 2x squared. So I found the total cost and then the marginal cost as that. I found the price and the revenue function as that. And the next thing to find is my revenue. So my profit. Profit will be what? Revenue minus total cost. This is simple marketing strategies we know. Where my R is 5x minus 2x squared minus my total cost function, which is 8x squared minus 30. You should be able to do this differences. We take them coefficient by coefficient. Let me expand this variable. So I have negative 2x squared minus 8x squared plus the 5x. Negative multiplying negative becomes positive 30. And this will be equal to, what do I get here? Negative 10x squared, because of they are the same, plus 5x plus 30 as my profit function P. So I'll use equation 3a. 3b can find the marginal profit, which will be the derivative of my profit. So if I use the power rule again, you realize I'm going to get 2 times negative 10x plus 5. Differentiating a constant gives you 0, so I don't write anything. So let me do that. If I apply the power rule here, I have negative 10, 2x2 minus 1. If I apply the power rule here, I have 5. Already x is to the power 1, so I have 1, x to the power 0. That's 1 minus 1. A number to the power 0 is 1, so that's why I have just 5. So I'll have this as equation 3b. This is as equation 2. Oh, I didn't find the marginal revenue. Sorry, 2a. So the marginal revenue, MR, will be the small change with respect to my revenue. If I still use a power rule, I'm going to get 5 minus 4x. Please verify this with the power rule, 2b. And then I'll use my total cost as 2a, then its marginal as 2b. What information can we make out of this for the manager? So let me rewrite everything. I have a total cost as x squared plus 30, that is it. Now the marginal cost, I had 16x, so let me shift this. That is the 2b as here. Okay, then I have the revenue as I had it as 5 minus 4x, 5x minus 2x squared here, and then the marginal revenue, that is 2b, I had 5 minus 4x. So let me use this as another color. Let me use green. Alright, now we had a profit, that is 3a. We had it as negative 10 x squared plus 5x plus 30, and we had the marginal profit to be equal to, that is 3b, negative 20x plus 5. So let me use another color here, make it that. Oh no, this is not so cool. This is not so cool. Let's use this. Okay. So these are my equations. I can have a table giving me much data set or information from these preambles. So I have TC. I have P as the profit. No, let me have it as R. I have the profit here. So I don't need my sheet again, so let me just extend this. Oh, sorry. I have my MC, I have my MR, and I have my MP. Until I do this, I can tell the story. But let me add another column. Oh, there's no insert column here. So let me just change everything here. Here's my, I have this as my X number of productions, my TC, my revenue, my profit, my MC, MP, marginal revenue, and marginal profit. So production 1, the first movie, the second movie, oh, what is this? The second movie. Let's take it through to let's the 5th production. Okay, now what will be the total cost? I need to write the function, so it's equal to 8. It is this one here. So it is 8 times x squared plus 30. Oh, sorry. This is equal to 8 times x is this guys here. all squared plus 30. I enter, I get 38, which is expected. When x is equal to 1, you get 8 times 1 plus 30. You're going to get 38 if you do it very well. So I can now drag this whole thing. I have that the revenue is equal to 5 times, I pick the first production, minus 2 times, no, it is 2 times the production square. So I need to extend this. Sorry for, oh, too bad here. So this is equal to, I'm picking the r. R is giving us 5 times x, so this is x, minus 2 times x squared, so carry 2. Then I can drag this for the first 5 production. So realize that the revenue is reducing when it goes to 5th production, and profit is equal to negative 10 star x. So x is the first unit, it is x squared. Okay, so I need to bring a bracket around it and then take it square, plus 5 times the same x plus 30. So when I drag this one, this is the profit. If the revenue is reducing per production, that is expected, the profit is also reduced. And the marginal cost is equal to just 16x, so 16 times the first unit here. I can find the marginal cost of that extra production. Marginal revenue, it is 5 minus 4 times this x. Please, you must take your time and type the functions out well in the Excel, because garbage in, garbage out. Marginal profit is the last thing, that's negative 20 times x, that is the first unit, plus 5. Then I can drag this. That is all you do. As to whatever story you must tell, I put it to you that it's up to you. So let me have a table around this one, just to make my life easier to see what I've done. Okay, so what is happening as production increases, what is happening with revenue, the profit, what is happening with respect to the marginal one, that is our interest here, but that's dealt with the application of the derivative. At extra production, what is happening with the cost? At extra production, what is happening with the revenue? At extra production, what is happening with the profit? And so this is how you're going to use Excel to generate this data and then speak to it. I hope it is clear. Please take your time and then go through this. Thank you.